I got a query from Summer a couple of days ago who wanted some help in solving this problem of finding the area of the shaded square EFGH. Try and pause the video and see if you can solve it for yourself, and if not, let's jump straight into the video and learn how to solve it. Hello, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success to this wonderful video where we are going to learn how to find the area of the shaded square. Now the query may look very simple, it may look very simple and straightforward, but actually it's not. So let's learn how to do it. In case you are new here, I would suggest that you should subscribe to the channel by clicking on the link below the video. So let's jump straight into the video and learn how to find the area of this square. So now as you can see, there is a bigger square ABCD which has a side length of 10 plus 5, which is 15 units, and it has been divided into two parts such that one part of it is 10 and the other is 5. That means each part is divided in the ratio 2:1, and joining these lines, as you can see in the figure, we have got another square, smaller square inside, the red one which you see, which has been shaded, which is the square EFGH, and we have to find the area of that. Now to do that, before we go on to find the area of the square, I would like to show you a theorem of proportionality. So let's discuss about that. So here what we are given is that there are three parallel lines and there's a transversal, and the parallel lines are dividing the transversal in the ratio 2:1. Now the theorem of proportionality says that in case one transversal is being divided in the ratio 2:1, then no matter how many transversals I draw, whether it's a transversal like this or a transversal like this or a transversal like this, all of the transversals will be divided in the same ratio, which is 2:1. So this part will be 2, this will be 1, this will be 2, this will be 1, this will be 2, and this will be 1. Now after knowing this concept, coming back to the question that we had where we had to find the area of this shaded square. Now if what I'll do first of all is to construct a line which is parallel to the line EF and to the line DG, and it should pass through the point A. So to do that, I construct a line which is parallel to both these lines. Okay, and as you can see, now there are two transversals, which AD is one of the transversals, and let me name these points also. Let this point be P, Q, R and S. So AD is one of the transversals which is passing through these three parallel lines, and AS is the other transversal which is passing through these parallel lines. Now as we can see, AD is being divided in the ratio of 1:2, so that means this is 5 units and this is 10 units. So obviously in this thing also, if we see that if the length of AE is X, then according to the theorem of proportionality, the side length of EH would be 2x, because it will be twice of that, because it is another transversal which is passing through the same three parallel lines, and it will be divided in the same ratio as the earlier transversal. So if now looking at this triangle, now similarly from here also we can see that in the triangle ABP, you can see that again AB is being divided into two parts, then obviously similarly we can say that this is X and this will be 2x. Now let's try and find the area of the square. We know that the side length of the square EFGH is 2x, so obviously the area of that will be 2x times 2x, which should be 4x square. Now this bigger square ABCD is not only it consists of the square EFGH, but it also consists of four triangles, namely triangle ABE. Keep going along with me. Triangle ADH, triangle DCR, and triangle CBF. Now let's try and prove that each of these four triangles are congruent to each other. So to do that, we know that if this is a square, this consists of a 90 degrees angle, and therefore angle E is also 90 degrees. And similarly in this triangle, angle F is going to be 90 degrees, and the hypotenuse we can see in triangle ABE is 15 units, and the hypotenuse in this triangle FBC or CBF is also 15 units. And if one side of the triangle is x, the other side is also x, therefore by RHS congruency rule all these four triangles are congruent to each other. Next, what we'll do is try and find the area of one triangle. So let's find the area of triangle ABE. So you know that the area of a triangle is half times base times height, which means it should be half into the base of this triangle is x units. Now let me replace this multiplication sign by a dot so that we are not left with any confusion, and times height, and height, as we can see, EF is 2x units and FB is x, so the total height will be 3x. That means the area of one triangle would be 3 over 2 x square. And since there are four such triangles, the area of four triangles will be 4 times of this, which means it should be 6x square, since the 2 and the 4 get cancelled and it becomes 2 times 3x square, which is 6x square. So the area of these four triangles is 6x square. Now let me take a new page and continue to solve the question there. So as we can see that the area of the square is 2x, so the area of the square is the side is 2x, so obviously the area is going to be 4x square. The area of four triangles we can see we have just calculated, it was 6x square, and that should be equal to the area of the bigger square ABCD. And since the bigger square ABCD has a side length of 15, that means the square of 15 will be 225, which means that combining these two terms we get 10x square should be equal to 225, or x square should be dividing both sides by 10, we get x square should be 22.5 square units. Now if x square is this much, then the area of the bigger square should be 4 times of this, which means it's 22.5 multiplied by 4, which gives us 90 square units. Now that's all we had to find out, the area of the square EFGH, and we can see that it is 90 square units. I hope you learned something useful out of the video, and in case you did, don't forget to subscribe to the channel just below the video, or you can click on the subscribe button shown here. I recommend that you watch this video next, shown on the left, and or you can click on the playlist link below and watch any of the videos from that. And wish you a happy learning. Add an exponent to your learning curve. God bless.